This lecture we will study about the independent random variables, expected values, knowing probability function, and correlation and covariance. X comma y is a two-dimensional random variables. The probability of x given y is calculated as probability of x equal to x. So in this condition, we will be calculated as Pij divided by P star j, which is equal to Pi star. Here star represents in the ith place star means we will take how many rows we will have, and in star comes in the jth place means we will take all the columns. Okay, similarly, x comma y is a two-dimensional continuous random variable. Here, this is for discrete. In continuous case, we will be modified it as small f function, and the same process continues. In example 1, emission is used for a particular job in the forenoon and for a different job in the afternoon. So, joint probability distribution of x comma y, where x and y represents number of times the machine breaks down in the forenoon and in the afternoon respectively. That means x represents the breakdown in forenoon and y represents the breakdown in the afternoon. So here we have to examine if capital X and Y are independent random variables or not. So this is given. This is the given table. These are the x values and these are the y values. So here we have 3 rows and 3 columns. Now we are going to calculate x and y are independent or not. The formula is Pi star into P star j, which is equal to Pij, means our sum is independent. So first thing, let us take the I value as 0. Star means in the place of x is equal to 0. Star means we have to take all the column values, that is y values. So we are adding 0.1 plus 0.04 plus 0.06. The answer is 0.2. Likewise, proceed for x value till 2. So P1 star means we have to add these all the things, we get 0.4, and P2 star means also. Again, we will add these 3 numbers, we get 0.4. Likewise, we will calculate the P star 0 means here y value, j value 0 and star represents the row, the ith columns 0, 1, 2. So here we have to add 0.1, 0.2 plus 0.2, we get 0.5. Likewise, we have to proceed for P star 1 and P star 2. Okay, now we have to multiply and substitute in this condition. Here we have taken I and j as 0 and substitute all the known values. At the finally we get 0.1 means that is P00, that is 0.1. Likewise, first fix the ith value 0 and varying jth value as 0, 1, 2. We will get some values which is given in this table. Similarly, we have to proceed for fix the ith value is 1 and vary the jth value 0, 1, 2. Likewise, we have to fix the ith value as 2 and vary the jth value as 0, 1, 2. We get all the values and we will check it. Hence, the random variables x and y independent because Pi star into P star j, which is equal to Pij. Let us take this is Pi star, this is Pj star. What is the final answer? We will get Pij. Here I and j both are 0 and 0. We will get 0 and 0. Likewise, we will check it means this property hold. And next we will go to see about the example 2. The joint probability density function of random variable is given like this. So it is a f function, so it is a continuous values. Note that here x and y both are greater than 0. Find the value of k and prove that x and y are independent. First we have to find this k value and next let us go to check the random variables are independent or not. Okay, first of all, it is a continuous random variable. We know that the integration value, this is a two-dimensional random variable. So we have to take a double integration of this function, which is always is equal to 1. Okay. Next, we have to split this integration with respect to x and y. And normally, it is an integration part. We have to integrate this with respect to y. And in the second part, we have to integrate this function with respect to x. Finally, we get k is equal to 4. Next, we are going to check about the function is independent or not. What is the condition for continuous random variable independent? Fx of x into fy of y, which is equal to fxy. This thing we have to check. What is fx of x? This is the integration value of 0 to infinity. Our function into, that means that expected value of function into dy. Here, fx of x means we have to differentiate, integrate the function with respect to y. So this is the final answer. Similarly, fy of y means we have to integrate this whole function with respect to x. This is the final answer. Next, we have to multiply these two things. We get the final answer. So this is our given f of x comma y. So both are equal. Therefore, the random variables are independent. Main thing, we know that the random variables are continuous. So the independent condition is we have to multiply the effects of x into fy of y, which is equal to whole f of x comma y condition. Okay, this is the tutorial problem. What we have to find the function f of x comma y double random variable is given, and we have to check x and y are independent or not. We note that 0 less than or equal to x. So the x value starting from 0 depends to what's the value? That is minimum value is 0 and the maximum value is infinity. And y less than infinity means it comes out of 0 to infinity. Okay. Like this, we have to find and we have to check x and y are independent. So it is given in the interval format. So it is a continuous function based upon the before problem. Likewise, we have to proceed for the answer. Next, we're going to say about the expected values of the two-dimensional random variables. Generally, expected value means it is a mean. So, x comma y is a two-dimensional discrete random variable. In the discrete case, the expected value is in one-dimensional random variable. The expected value is it is a summation of our function into probability function. In two-dimensional case, we have to take two summations. Likewise, for continuous random variable, we have to take double integration into the function of g and f with respect to dx and dy. Okay, the joint probability mass function is given here. We have to find the expected value of x, expected value of y, and expected value of x. So it is a discrete case, right? The numbers are given in a discrete manner. So what is the formula for E of x? E of x means it is a one-dimensional random variable. So the discrete case means the formula is summation cos into P of x. So first we have to take this is x value, x is minus 1. What is the probability value? 1 minus 1. Okay, in the minus 1 case, the probability value is we have to add these both things. Minus 1, these two values are no. So we have to add 1 plus 2, 3 by 8. So this is the probability value. And this table represents those things. We have to add all the probability values. This is Py of y to column. This is Px of x column. Into, what is the next x value? 1. 1 into, in the case of what's the probability value? 5 by 8. So we have to multiply both things and add. Finally, we get the expected value. Likewise, we have to proceed for expected value of y. What's the formula? Summation y into p of y. So this is y value 0 and 1. So 0 into 4 by 8 plus 1 into 4 by 8. So the final answer is 1 by 2. xy means it is a two-dimensional random variable. So we have to take double summation of that particular values. Single variable means x into p of x. Then what about for double variable? Xy into p of x comma y. That is the formula. So xy means first we have to take x value as so this is and this is y value, right? Y is 0 into minus 1 into 1 by 8 plus 0. So we have to multiply each term 0 into minus 1 into 1 by 8, 0 into 1 into 3 by 8, 1 into minus 1 into 2 by 8 plus 1 into 1 into 2 by 8. Likewise, we have to proceed. The final answer is 0. Next, this problem, we have to find the expected value. So this is also a single variable. But the function is given in the type of two-dimensional random variables in terms of x and y. Next, we have to check the limit. So it is given in the format of interval. So it is a continuous random variable. First, we have to fix the limits. 0 less than or equal to x less than y less than or equal to 1 means x value lies between 0 and 1. So this is x value lies between. First thing, we have to calculate what is the expected value formula. Single random variable means x into our function into dx into y dy. Why we are taking double integration? Because the function is given in the format of both variables x and y. So we have to differentiate double times. So here we have to substitute our f value. Next thing, we have to fix the limits. Okay, before going to fix the limit, we have to check the interval. Dx into dy means first we have to in the inner limits, we have to write the limits for x. Here x lies between 0 and y. So the limits are 0 and y. Next, we are going to write the limit for y. Here y lies between x and 1, but x lies between 0, starting from 0, because the outer limit is always, we have to focus for constant limit. So y lies between 0 and 1. After that, we have to integrate with respect to x first thing and substitute the inner limits. After that, we have to integrate the thing with respect to y and substitute the limits. The final answer is 1 by 8. Next, covariance of two-dimensional random variables. So the covariance, it is defined as the useful measure to study the relationship between the variables. So its formula is we have to difference the expected value of xy minus expected value of x into expected value of y. Okay. Before going into that, we have to know some tips. If x and y both are independent, the covariance of x comma y is 0. If x and y are independent, means this value e of xy is directly which is equal to e of x into ey. Substitute this in this equation, we directly get the answer as 0. And we know that the variance is always equal to standard deviation squared, or its standard deviation is equal to rate of variance. This formula. Next, this is very important. Covariance of ax comma by. Here a and b both are constant. So we have to take this constant outside the covariance and directly come like that a into b of covariance of x. So it is both are equal. Next, variance of x plus y. This addition property is always equal to variance of x plus variance of y plus 2 into covariance of xy. These are the very important results for solving the problem. Next thing, we are adding some number to the covariance variables, which is always equal to the covariance of x comma y. And in the case of variance, suppose we are taking the constant which is attached in the random variable, this is always equivalent to the constant square into variance of x. This is the formula for variance of a sum of random variables ax into by. What I have told, if any constant is attached in the random variable, we have to take this outside the variance, means it will become square the number. So a square into variance of x plus b square into variance of y, and this is addition formula, right? So 2ab into covariance of x comma y. Okay. So in this problem, x and y are two independent random variables. Here variance of x and variance y are given. We have to find this term. So 4, 2 are constant, right? So we will apply this formula. We have to take the 4 outside the variance, means it is 4 square 16. Next, minus 2 whole square means 4 minus 2ab. It means 2 into 4 into 2, the 16 covariance of x comma y. Okay, note that x and y are independent variables. We know that covariance is 0 for independent variable. So this last term is a 0. So after solving this, we get the final answer as 156. This is for tutorial problem for your practice. Here the joint density function is given. So density function means it is a continuous random variable. So you have to calculate expected value of x, expected value of y, under the expected value of xy and this formula. So here I have given the formulas and the tips. You have to solve it and check the answers. Okay. So it is a continuous random variable means, and it is also two random variables. Two random variables means we have to use the double integration x into f of x comma y dx dy. So here x is given. F of x comma is this function. And next we have to fix the limit. Dx comes front of x. We have to fix the limit for x. So what is the x limit? I mean, fix the limits for y. So the y lies between 1. This is 1. 5. Next thing, x lies between 0 and 2. So this is, so both are constant limits, so no problem. We have to write any one limit front or back. That is not a problem. Likewise, we have to find the e of y. E of y means what's the formula? Y into our function. E of xy means xy into our function. Okay. And this is very important. 2x plus 3y. So we can directly write it as 2x plus 3y. And we have to multiply these things. And here that's a plus no. So we have integrate 2x into xy 96 plus 3y into xy by 96. So here we have separate double integration part. So check it. Finally, we will get these answers. So the two random variables x and y for joint probability density function, again it is a continuous random variables given. We are going to find the covariance of x comma y. We know this. This is the formula for covariance. After that, we have to calculate the 3x value. So it is double random variable. So we have to take the double integration. It is 8 by 3. Next, e of y means formula y into f of x comma y into dx into dy. So this answer is 31 by 9. Next, we are going to find the expected value of xy. So this is xy, double integration of xy into our function dx dy. So this is after solving these steps. The final answer is 248/27. Substitute in this covariance formula, the final answer is 0. So this problem is based on covariance. Here, check it. Probability mass function means it is a discrete case. Check it, x value is 1, 2. So this is a discrete separate number. Y is 1, 2, 3, 4 means it is also a separate number. So it is a discrete case. So using that discrete case formulas to find the covariance. Thank you.